so you don't get as hot. In the tropics, it doesn't vary that much. You get, say at the equator, it goes, the sun is 23.5 degrees one way in the sky, and then goes to the other season, 6 months later, 23.5 degrees that way, and right overhead passes through the equinox. So in the tropics, you always have very high intensity.
In the diagram, what's the yellow line across the Earth?
That's probably particular latitude, I guess. That's probably, I don't know where they made it. It looks like it goes through New York or something. That's my guess. It's a line of latitude. Okay. Unless it's too high to be the tropic cancer, I guess.
I think that in the two diagrams above, they're illustrating where on the Earth that they're showing the relative change in intensity.
Sure, but if she's asking for this, what is
Yeah.
that?
Yeah, no, that's where it's spinning.
Yeah. The
So
motion
that would be a line of latitude. Question is it really a?
No, it's the diagram. It might be
Yeah,
the diagram.
just illustrating where the point on the Earth is.
No, it's really a little different display. So see this point up here, this thing is a circle that's basically slices the Earth perpendicular to this axis. And this is above where that circle is. Of course, these represent the sun's radiation, sun's rays, but here, this looks like it goes through New York, right? The latitude of New York for one reason. That's what it looks like. I don't know, maybe it's published.
Maybe someone just really didn't know where the equator was.
Okay, we talked about the precession of the Earth because of the influence of Jupiter, especially, and the Sun, other planets. By the way, the Earth, and we probably on Earth, we owe our lives, literally, to the moon, in part. Because without the moon, the Earth would never have established a stable axis. The fact that the axis is stable, it turns out, is in part, or large part, due to the presence of the moon. It stabilizes its rotation. Due to the other influences other than the moon, the Earth would otherwise wobble a lot. So you could never establish a consistent set of seasons. Therefore, it's been very difficult for terrestrial life to gain hold.
Why does the Earth have an axis at all?
It's spinning. Anything that spins, you spin about some kind of...
I mean, why is it tilted? I'm sorry.
Why is it tilted? Well, I think it's just, we don't know exactly. We think we know that it may have been due to, well, let's back up a little bit. In chapter, I forget what it is, when we get into the solar system, the origin of the solar system, we notice that all the planets spin one way, except for one or two. But basically things spin one way and they all orbit the same way. So there's a kind of, they're not randomly orbiting. That's because there's a belief of kind of a nebula that was, whenever you have something that's big, it contracts like it will spin up like a skater will spin up, go faster and faster and faster when you contract. And so everything has this angular or the spin basically embedded in the cloud, and then they condense out of the cloud and they're still spinning. Now, then you would say, well, they should have all spin straight up and down, like Jupiter's very much like that. It's a big gas planet. Saturn. But even Saturn has a tilt. Mars has a tilt. Earth has a tilt. Most planets have a tilt. Why? Because people speculate because of accretion, planetesimals in the terrestrial area. Then they hit randomly, and so you're going to get some kind of twisting, and then the moon is believed to have come about due to catastrophic collision with some planet-like body, and then that caused that could have caused this kind of skew of what would otherwise be a spin like this and knocked it. so it's going like this. Venus is spinning backwards slightly, so people think, well, maybe something hit it, knocked it back, knocked it the opposite way, and it hit it at the right angle. But that's speculative, we don't really know. Can't really recreate that history. A lot of prior long history.
Has it always been tilted, like as far as we know? Or did it change?
Well, you know, this, I can't really answer that. Maybe if you go far enough back, you expect it would be, straight up and down, and maybe the moon hit it, you know, so it twists over.
Is it all based
And
on-
with the moon, it stabilized its orbit, so I don't know if it was wobbling a lot before that or not. Probably wobbling a lot. So that's in the literature, I guess, I don't know the answer to
Is
it.
it a possibility that the meteor that hit Earth caused the moons, caused it to go at an angle?
What's that?
Is it a possibility that the meteor that hit Earth that caused basically the moon, is it a possibility that caused the Earth?
Yeah, as I said, I was
Oh.
saying that, basically that big impact might have done it. But again, your question is, as far as we know, it's been spinning like that for a long time.
Is it possible for planets to be created with a tilt, or does something have to put them off?
That's all speculative, it's astrophysics, so.
Well, it's, people think that things, came about, you say creative, formed, early on formed, it would be natural to form with something that's pretty much straight up and down tilt. But then again, you're accreting with random hits, so it'll tilt differently or spin at different rates, depending on what hits it, where it hits it, how it hits it. So that's, people do simulations, and maybe you could look, maybe the most useful thing is to look up simulations, like go Google simulations of Earth's or planetary formation, and then you get a good idea of that. You know. They do a lot of very interesting simulations, especially some of the stuff we'll see, some of the results of simulations of the moon's believed origination from this the impact theory of the moon's okay. There's a tropical year and a sidereal year. Because of the precession of the tilt, then the sidereal year and the tropical year are a little different by about 20 minutes. So this tropical year, I think is 365.26 days, and the sidereal year is something like 365.24 or something a day. Now, the moon. Been talking about the moon. The Earth goes around the sun. The moon goes around the Earth. Now, the orbital plane of the Earth, which is the ecliptic, that's where all the planets are pretty close to. That is, all the planets, except Mercury really, are all very within just a degree or two of that orbital tilt. So, but not the orbital tilt, let's just say the ecliptic. And then that means they will follow a path right along the ecliptic, just maybe a little bit below or a little bit above. You can see the above and below looking at Saturn, because the ecliptic is going like this at the night. All right, so it'll come down like this, and Saturn's above and Mars is below. So they have a little bit different angle of orbit. The moon has a little different angle of orbit than the ecliptic, about plus or minus 5 degrees. So it turns out the moon can get in the way of the sun sometimes, but not all the times when it goes around. You'd think, oh, it goes around, gets in the way of the sun, we have an eclipse. If the Earth gets in the way of the sun, for the moon, we have another eclipse, a lunar eclipse, solar eclipse when the moon gets in the way of the sun. But the moon is typically at an angle relative to the sun. So maybe it goes above the sun or below the sun when it passes by. And when we say passes by, we're talking about a new moon, where we basically don't see the moon at all. The sun is there in the daytime, the new moon is right near the sun. It's so bright you can't see it. But then the moon is moving in orbit, and so then it's moving counterclockwise if we're looking down the North Pole. And it's all, as we look out to the moon, then we start to see the sunlit portion of the moon. And we'll see that rising night after night as a brightening, or we say waxing crescent. So it looks like, let's see. Talking words. So this is a crescent, it's a new crescent. And that's the bright area. And it's basically pointing down at the sun. So the sun is down here someplace, here's the horizon. So the new crescent, or waxing, we say waxing crescent, because the next night it's going to be over here, having gone a little distance. It has to go, takes about 30 days to go all the way around, so that's 12 degrees per day. And so it goes up here, and it'll be a little bit fatter, and fatter still, until it gets all the way around here, and then it's half lit, like this. That's the first quarter. So this is a new crescent. The first quarter then would look like this. Okay. And that basically is going to be, whereas the new crescent is going to be up very early in the evening. The first quarter is going to be at sunset. The first quarter is going to be right at its highest point in the sky. And then it will set, 6 hours later. Then it'll get brighter still, and you have this waxing gibbous. So here, let's see. Okay. So here's the first crescent. This a little bit. They should flip this. It looks like they didn't flip this. So it should be pointing. If the horizon is pointing down, it's rising down here, it's pointing down. Always points toward the sun. First quarter. Then this is called the gibbous phase. It's not quite full, but it's brighter than it is at the quarter. And then it gets to the full moon. Then it's basically opposite the sun. But it doesn't necessarily get into the shadow of the Earth, because again, is tilted, its orbit is tilted relative to the ecliptic. Then waning gibbous, third quarter, waning crescent, and back to new moon. You don't see it at all. So that takes about 30 days. 30 days from new moon to new moon. The sidereal month, though, is about 27 days. That is relative to the star's go.
So tonight's gonna be like a new moon.
Yeah, I think tonight might be new moon. Let's see, tonight is Tuesday. I think it's tomorrow might be, maybe. And so a week from now, then, around midweek, you should be able to look up and see a waxing crescent. Here's this tilt, about 5 degrees, that precludes the moon's shadow from hitting the Earth if it's in the new moon phase. But if it's a different time of year, then that shadow can fall on the Earth. when that shadow falls on the earth, and you see that the sun is different. It's eclipsed by the moon. It's a solar eclipse. So, in fact, I'm sure people have seen at least a part, how many people have seen a solar eclipse? At least partial. How about a full solar eclipse? How many people see it? Lucky. I haven't seen one. But next year, about this time, August 21st, I guess it is, next year, there will be a full solar eclipse that will run right through Portland and north, what is that town up there? There's, I forget, but anyway, it goes east of the Sierra, north of Shasta, coming down through Idaho, I guess.
That's being worth the drive to go over there.
Huh?
That's worth the drive.
Oh, yeah.
There are towns
Better
already
be there
preparing for
the
it.
day before, probably get traffic jams.
Mhm.
Yeah, let's go to Fish Road.
That's you go make like a couple of weeks plan, and just make sure you're there the entire
Oh,
week.
yeah, I think probably people are saying, plan now, a year ahead.
Mhm.
Unless you just wanna stay in your car overnight or something like that.
There was an article that
Every
said,
place you
go
can
for
book.
5 minutes of just.
there was an article that said some hotels are already booked up for like the entire
So
week.
a full solar eclipse, then you can see stuff that you never saw before. You can actually look toward the sun, and you see this corona that's usually hidden by the glare of the sun and the scattering in the daytime sky. And you'll be able to see maybe some of the chromosphere, the pink chromosphere around, get some pictures of these spectacular.
So for the unfavorable for eclipse, do we get like a partial eclipse or anything, or?
For the what? For the,
Wait, but for the diagram, do we get like a
Oh.
partial eclipse?
No,
or-
unfavorable won't have an eclipse. Shadow won't fall on the earth at all. Partial eclipse happens when you're in, there's a shadow, but you can be in the, we call the umbra, and then the sun is totally obscured. But then if the sun is partly obscured, then it's still in shadow, but it's a partial shadow. Maybe we call that the penumbra. Okay, so we'll continue this later next time.